Welcome. In our final example discussing indefinite integral, we are going to do an initial value problem again, a word problem where we will find the demand function given the marginal revenue. You might recall that we did a problem like this earlier. So in the second example on slide 8, we did a problem where we found the demand function given the marginal revenue. In outline, we found the general antiderivative for marginal revenue. That gives me the revenue function up to a constant. Then I find the constant of integration using the fact that revenue is equal to 0 when the quantity sold is 0. And finally, we find the demand equation in the form P equals the function of Q by using the fact that P equals R over Q. In outline, we have to do the same thing. The difference is that dr over dq is a more complicated function. This means the integration takes a little bit more work. And since we are being asked to simplify the answer as much as possible, I have to also do a lot more algebra. The first step is to find the indefinite integral for this function, multiplied by dq, then do the indefinite integral. So I have to do this indefinite integral. The indefinite integral of 900 dq over cube of the quantity 2q plus 3. Our rule of thumb tells me to try the substitution u equals 2q plus 3. du is 2 dq. So dq is du over 2. In the integral we are trying to do, I have the 900, a constant factor, times dq, which is du over 2, divided by 2q plus 3 power 3. I am going to bring it up to the numerator, so I have to use a negative exponent. The quantity inside the parenthesis is u, so it's u to the power negative 3. Now I can integrate this using the power rule. 900 divided by 2 is 450. If I add 1 to the exponent on u power negative 3, then the new exponent will be negative 3 plus 1 or negative 2. So an antiderivative is u power negative 2 over negative 2. And then I will have plus constant of integration. 450 divided by negative 2 is negative 225. And if I substitute 2q plus 3 for u, I get negative 225 times the quantity 2q plus 3 to the power negative 2. Since I'm going to have to do quite a bit of algebra, let me write this using fractions rather than negative exponents. So I'm going to take u to the power negative 2 to the denominator, and if I go back to u, I get negative 225 over 2q plus 3 quantity squared, plus the constant of integration. To find c, I use the fact that when q is 0, r is 0. So if I substitute 0 for q, this whole expression should be equal to 0. So substitute 0 for q and set that whole thing equal to 0 and solve for c. The first term here is negative 225 over 3 squared, negative 225 over 9, that is negative 25. 0 equals negative 25 plus c, so c is 25. I plug this back in this, and that gives me the revenue function in terms of q. If I divide this by q, I get p. I would be done, except they are asking us to simplify the answer. So I need to simplify this. That means I need to combine the two terms into a single fraction first. So the common denominator is 2q plus 3 quantity squared. The first fraction already has the denominator. In the second fraction, I have to put that in the numerator as well. Now I can combine the two fractions into one. To simplify the resulting numerator, I will have to multiply this out and combine like terms. First I'm multiplying out 2q plus 3 quantity squared. 2q quantity squared is 4q squared, plus 2 times 2q times 3. 2 times 2 is 4 times 3 is 12 times q is 12q. And then plus 3 squared is 9. I have to multiply all of this by this 25, so I need to distribute the 25. 25 times 4q squared is 100q squared. 25 times 12q is 300q. 25 times 9 is 225. Now I can combine the like terms. Minus 225 plus 225 is 0. So the numerator is 100q squared plus 300q. I'm going to factor the numerator. I can pull out 100q, so the numerator is 100q times the quantity q plus 3. P is r over q, or r times 1 over q. R divided by q is r divided by q over 1, which is r times 1 over q. if I multiply this by 1 over q, the q's cancel. So I get 100 times q plus 3 over the quantity 2q plus 3 squared. This concludes this example.